We're going to go over 3.4 factoring expressions. Your essential question is how can you use the greatest common factor to factor expressions? How do we find the greatest common factor of two numbers? So there's two way. There's a couple different ways, but we're going to go over two ways to find the GCF, the greatest common factor. One way is you can make a list. So let's say I'm trying to find the greatest common factor of 28 and 36. Well, step one, you can list the factors of both numbers. So factors of 28, 1, 2, 4, 7, 14, and 28. Factors of 36 are these. For step two, we would go through this list and circle the common factors. Then we see that the greatest factor that is circled is 4. So therefore, the greatest common factor of 28 and 36 is 4. Now, making a list is not my personal favorite, for main reason being that if you don't know your multiplication tables well, you can easily skip numbers and you might not find the greatest common factor or find it incorrectly. One of the good things about this is you know that the last number that you're going to go to is 28, and down here the highest number you're going to go to is 36. A factor can't be higher than this number, right? We can get 36 because 1 times 36 gives us 36, but we can't get any higher than 36. Second way would be to use prime factorization of both the numbers and then circle the factors that have in common. Now they're showing it again by making a list of what multiplies. I would prefer this. I would prefer to use a factor tree. So for example, let's take 28. Right. Now, two things that multiply to get to 28. Well, it's an even number, so I know I can multiply by 2. 2 by, let's say you don't know, you can use a multiplication table, or just divide this by 2. 2 multiplied by 1 will give us 2, and then 2 multiplied by 4 will give us 8. So that is 14. Then this is a prime factor already. The only thing I can go into it is 1 and 2, so we're going to leave it alone. We're going to continue with the 14, and that's 2 and 7. So there, our list ends with these right here. So I have 2 multiplied by 2 multiplied by 7. Hopefully you remember this from 6th grade. All right, so there's my list for 28. Now, if I could do the same thing, I'm actually going to write it over here. It's going to be the same as this right here. So 2 by 2 by 7. Now we're going to do the same thing for 36. Now we have it right here. So I know I'm going to have to eventually get these. But let's try to do it on our own. So I'm going to go ahead and erase this as well so I'll have more room. And go with 36. Well, any even number, you can always use it by 2. So let's try 2 first. Let's say 2 times something. Let's say you didn't know what this is. You could always just divide it by 2. I know it goes into it once. Subtract. Bring down the 6. And 2 times 8 would give me 16 with no remainder. So this right here is an 18. Then I know 2 by 9 gives me 18. And then I have to factor this 9. So now the list that you're going to use is right here. So it's 2 by 2 by 3 by 3. And I'm going to find the greatest factor that they have in common. So There's 1, 2. And there's actually another 2 right here. So that means if we had 1, 2, and then we had another 2. So 2 times 2 is 4. So you find the product of the common factors. So we had a pair of two pairs of 2s. So there's 1, 2. So the common factor here was 2. The common factor here was 2. And we multiply all the common factors that we found. 2 by 2 gives us 4. Therefore, the GCF of 28 and 36 is 4. So this is the way I would prefer to do it when I'm trying to find the GCF as opposed to just making a list of all the factors. I'd rather just do a tree, but it's up to you, whichever you find easier. Okay, now we're going to go over using the greatest common factor. How do we factor an expression? So first you have to find the GCF and divide it. So this is the opposite of distributing. We can check our answer by distributing, which is what we learned in the last section, and see if we get the same thing that we started with. So here's an example, right? Let's take this example right here. And we're going to go ahead and go over this. So factor the expression using the greatest common factor. The expression 9b plus 21 factored using the GCF is blank. Okay, so we're going to have to find, first we're going to find the GCF, which I said it right here, it's going to be 3, but let's try to find it on our own. So let me do a factor tree for 9. Let's try that again. All right, so for 9, I know the two things that you can do to multiply are 3 and 3. And that's it for my factor tree because these two are prime. Now let's do 21. I know for 21, I can do 3 and 7. And the greatest common factor here is a 3 here and a 3 here. So it is 3. Now, what am I going to do with that 3? Well, you're going to take the 3 and you're going to divide your expression by 3. Any term you see in here. So this gets divided by 3. This gets divided by 3. 9 divided by 3 so give you 3. We can't forget that b. These two are positive, so I'm going to leave the positive there. 21 divided by 3 gives me 7. And because I took out a 3, right, we divided this by 3, I'm going to need a 3 outside the parentheses. So the GCF is 3, so we divide it by 3, and we're going to get 3b plus 7 all multiplied by 3. So 3 outside the parentheses, 3b plus 7, and then close the parentheses. So this expression factored is going to look like this. Now we can check to see if we are correct. And how we check it is by going backwards. So we're going to go ahead and factor. Well, not factor. We're going to go ahead and distribute. So remember, we have 3b plus 7 multiplied by 3. So remember, we have 3 orders of 3b plus 7. And what that would look like is if I have 3b plus 7 plus 3b plus 7 plus 3b plus 7. Remember, I used the example that this is an order at a restaurant and you are ordering 3 of the same orders. So like 3 number ones. For example, this can be you want 3 burgers plus 7, let's pretend there's an F here, fries for you. and then your other friend wants the same thing, and then your other friend wants the same thing. So you just order 3. Let's say this was all number at a menu at like McDonald's or no, this was all a number 10. Or you order 3 number 10s, and this is all the food that you get. So just an example of what distributing actually means. When I multiply all this out, these two are positive, so I'm going to get a positive. 3 by 3 is 9 with the b at the end. 3 plus 7 is 21. So it does check out to what we started with here, which is 9b plus 21. Right? These two, they're the exact same thing. That is a way for us to check our answer to make sure that we got it correct. Or if you get it wrong, then you could see by checking it here, and you can get an idea of what you did incorrect. Okay, so let's go ahead and let's try these 2 examples. Starting with factor the expression using the GCF, right? The expression 20z minus 8 factored using the GCF is, so it's saying we find the GCF and then we factor it. Go ahead and try it on your own using this as an example, and then we're going to see if we get the same answers. So you can go ahead and pause the video, try it with people at your table, and see if we get the same thing. Now, when you're ready to double check it, go ahead and unpause it and finish watching the rest of this. Okay, so first step, I need to find out what in the world the GCF is. So you might already know it, but let me double check. So I'm going to do 20. Let's think 2 and 10. Now I could have done 4 and 5, but 2 is already prime, so I like just starting with at least one prime number. And this would be 2 and 5. So for 20, I'm going to get 2 by 2 by 5. Right? It goes like that. And now I'm going to do the same thing, but I'm going to find it for 8. And just FYI, remember, this is a negative 8 right here, because the negative is right next to the 8, or this minus. Remember, I like to tell you about to think of them as the same thing, as a negative and a minus. So this is a minus 8 or a negative 8. Okay, again, I'm going to start with 2, just because I like one of my factors already being prime. 2 times 4 gives me 8, and then this can be broken down to 2 by 2. So if I want to find the factors of this, factors of 8 are 2 by 2 by 2. The common factors that they have, so to find the GCF, well, there's a pair of 2's, so I'm going to write a 2 there. And there's another pair of 2's, so I'm going to write another 2 here. So 2 by 2 equals 4, right? So the GCF of these is 4. If that was too fast, you can go back, rewind it, and go back to see what I did. Now, I'm going to take a 4 and divide each of these 2 things by 4. So 20 by 4 will give me 5z. Negative 8 by 4, well, different signs. This will give me a negative. And 8 by 4 will give me 2. Now, if I multiply this out, if I distribute it, it should give me 20z minus 8. And that's how I can double check that I did this correct. So 4 by 5 is 20 with the z. So that's right. And 4 times negative 2 does give me negative 8. So I just confirmed that this is right. Now you're going to go ahead and do the same thing for number 2. So let's start with a simpler one, which is 15. 3 and 5. So that's done, right? We already have 2 prime. And now I'm going to try to do the same thing, but this time for 65. So I'm going to do 65. Well, I know that it ends with a 5, so I can do 5 by, let's say that I didn't know what this was off the top of my head, so let's divide this by 5. 5 goes into 6 once. 5 times 1 is 5. Bring this down. 5 by 3 gives me 15. So my factor here was 13. Now I can stop here because these both are prime. Looking to see what they have in common. The only thing I see here is a 5. So the GCF is equal to 5. Knowing that information, we can go ahead and simplify or factor this expression by dividing each of these by 5, which we just did when we found the factor, right? There's a 5 on the outside. 15 divided by 5 gives me 3W. This is positive, so I'm going to have plus. And we just figured out that 13 divided by 5 was 13. If you don't remember that, go ahead and rewind it to where I did 65 divided by 15. And here is our answer. You could always double check it by distributing. Remember, when we distribute, you take the number on the outside of the parentheses and multiply it by everything inside the parentheses. This is like you have one order, or you're wanting to buy this. So 3 wings plus 13 of something else. And you want 5 orders of that. So this is like if I took this 3W plus 13 and multiplied it out 5 times. 5 times 3 gives me 15, the W. So it gives me there. So this checks out. And 5 times 13 does give me 65. So that checks out. Okay, that's it for this lesson. And go ahead and try your big ideas, 3.4. Go ahead and try the assignment for today. Let me know if you need any help.